Hello friends, this is a computer networks class 6. Today we learn network delays. So there are 4 types of network delays in the computer network: transmission delay, propagation delay, and queuing delay and processing delay. And the first one is transmission delay. Transmission delay is also known as packetization delay, serialization delay, and store and forward delay. So what is the fact transmission delay? The time required to put packets time requires to put packets into channel is called transmission. Means that here there is a device and this is a channel means physical wire. This is a host, there is a transmitter, and this here is a receiver. Transmitter put data frames into channel. Delay required to put the frames from device to channel is called transmission delay. Transmission delay is the time required to put the frames or a packet into the channel is called transmission delay. So the formula for transmission delay is the packet size and data transfer rate of the channel. Means that bandwidth of the channel here divided by the packet size divided by the bandwidth of the channel. Channel means the media. The transfer of media means here is a wire. It should be a copper wire, optical fiber, coaxial cable. So with the different cable, there is a different bandwidth. Yeah, data transfer rate also known as bandwidth. Okay. Now there is some unit converter from 1 KB is equal to 2 to the power 10 bytes, 1 MB is equal to the power 22 bytes. Okay. Now data transfer rate also known as bandwidth. The number of bits or bytes in one packet. These are some important terms in conversion we used in computer network while solving the questions. 1 kbps is equal to 10 to the power 3 bits per second. 1 mbps is equal to 10 to the power 6 bit per second. It means see that if bandwidth is 1 mbps means that 10 to the power 6 bits are put in a channel in 1 second. Here time conversion 1 second to millisecond, 10 to the 3 1 second to microsecond, 10 to the power 6. Here are the simple questions to find the transmission delay. Now the propagation delay. The propagation delay is a time required to travel a frame, last bit of frame from transmitter to receiver. Okay. Here the transmitter and here the receiver. After putting all packets into the channel, the packets will travel from here to here. The time required to travel from here to here is called propagation delay. It is a one-way delay, means that from here to here there is one way. If packets come from here to here, then two-way. Formula for packet delay is equal to distance from transmitter to receiver upon the signal speed, which speed packet will travel. Here the question again to find the propagation delay. Okay. Here the formula for propagation delay is distance upon signal speed, which signal will travel in a channel. The speed will be given in meter per second. Now, round trip propagation delay. Round trip propagation delay means it's a two-way, and the 2 into propagation delay means that transmit the packets to receiver. Here, the putting the frames into the channel called transmission delay, which will be a TX, and the and transfer the packets from the transmitter to receiver called TP, trans pro, propagation delay, and and receiver send again to packets from receives from receiver side to transmitter side. Then again one TP, means that here there is a transmission delay. After transmission delay, there is a one propagation delay, means transmitter's packet travel from here transmitter side to receiver side, and then here from here receiver side to again transmitter side. 1 TP for transfer or 1 TP for received. So there is 2 TP. So the round trip time is a 2 times of, if we ignore the transmission time, so there is a round trip time with 2 TP. Then what is a queuing delay? Queuing delay. Queuing delay is the wait time, means that if we transfer the packet from transmitter side to receiver side, but at that time the receiver is busy in another work, another data processing, so the transmitted data will wait here in the receiver's buffer. So that waiting time is known as queuing delay. So it can't be determined. If in question it is given, then we use to solve the question. But if it is not given, queuing delay is not given in question, we take it negligible. We take it and consider it negligible. Okay. Then the processing delay. Processing delay means that here the packets is sent to the receiver side. Okay. Means propagation delay. Here the packets wait because the receiver side is busy in another process, so that time is called queuing delay. Now if the packet gets a chance, the packet get into the processing, that processing time is not that processing delay, means packets goes to receiver side, receiver is busy, the packet stand in buffer for some time called queuing delay, and after standing in a buffer, the packet gets chance to processors in CPU for processing. The delay or time required to process the packets in receiver end called processing delay. It is also be considered as negligible if not given in the question, and it depends on CPU processing speed of receiver side. Now end-to-end delay, it's a one-way delay. One-way delay means the time required for the packet to transmit from one transmitter to receiver, means the time required to transfer packet from transmitter to receiver side. This is called end-to-end delay. The formula for end-to-end delay is first, the end-to-end delay is there is a first transmission delay, put the packets into the channel, then packet travel from transmitter to receiver, there is a propagation delay. Okay, then after packet reach to the receiver end, but the receiver is busy with another process, so the packets wait in buffer for their chance, so the queuing delay at receiver side. If the packet get chance of processing, then there is a processing of packet called processing delay by the receiver. So the end-to-end delay is T of X transmission delay, T of P propagation delay. But queuing delay and processing delay are too small or negligible, so it So we have to negligible or neglect these processing delay. But if there is if it is given a question, then we will consider it. Okay, then if we consider it, then there is a time with Q question queuing delay, then T for processing delay, PD. Here the diagram means that this is a transmitter side, this is receiver side, and this is channel. At the time at which the first bit transmitter put in channel, means here we start the putting frames into the channel. So this is the time required to put a frames into the channel called T of X. Okay. From here we are putting the packets into the channel, and packets will be transmitted into the channel. Here the last bit of frame put into the channel. When the last bit of the channel put into the channel, when the last bit of frame put into the channel, then from here we considered propagation delay. That this last bit is start traveling toward the receiver, and from after traveling it reached the receiver end. That time required called TP, propagation delay. Diagram for transmitter to receiver end transmission delays. Here the cases of network delay means that here if the transmission delay is less than propagation delay, this is a transmission is from there is a frame bit 1 and the very last bit of frame. The time required to transmitter to put this packet into the frame, it takes some time called transmission delay. And if the transmission delay is less than propagation delay, then this is a diagram. This diagram will be happened. If the patch channel is putting first bit of frame here, then with that bit will travel from up to transmission time. So the first bit reach here and the last bit of the bit is in the first of the transmission for a channel. So in case 2, if the transmission delay is equal to propagation delay, then there should be a diagram this. If we are putting first bit of the frame into the channel and the bit is traveling toward the receiver, at the T of X time we are putting the last bit into the transmission into a channel. Then the first bit we are putting in the channel will now is traveled, now reached at some distance. At that distance is equal to will be equal to the transmitter to receiver end. So the time at which time transmitter put the last bit of the frame into the channel, the time will be equal to the same as the transmission delay. In transmission delay, if transmission delay is greater than propagation delay, in transmission delay, the transmitter end put the first bit into the channel. The first bit will getting transmitted, and the transmitter are putting bits one by one into the channel. After some time, the first bit which is transmitted by transmitter into the channel are reached to the receiver end, but and still the transmitter are putting bits into the channel because these are 2-bit long frame. There is a frame which is very long, so the first bit which is put by the transmitter into the channel are reached to the receiver end, but still the transmitters are putting bits of the frame into a channel. So at that time transmission time is larger than the propagation delay, because the first bit of the frame is reached to the receiver end, but still transmitter is putting the frame bits into the channel which is greater than the propagation delay. Here the store and forward device, the layer 2 and layer 3 devices. Switches or router, if there is a transmitter and the receiver, and from between the transmitter and receiver there is a switch or router. So there is a T of X. This is channel 1 and channel 2. In between channel, the switches and router become. So there is a transmit TX, then TP, then here is a queuing delay to in switching and the processing delay in router. The router again send this to receiver. So again there is a TX and there is a TP. The store and forward delay. So there is queuing delay, processing delay, and transmission delay are the delays by store and forward device. We say here I store and forward device. What will it do? It take a packets frames from the transmitter end. So it take a queuing delay. It process the packet. So there is a processing delay, and again transmit it packet to the receiver side. So there is a TFX transmission delay. These three delays will combine to make a store and forward delay.